Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast, coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. You know, we just wrapped up KubeCon last week. I had a chance to get out to Seattle and get to KubeCon, and one of the big announcements that happened last week, amongst a ton of other ones, was a new thing from the folks at CoreOS, who are frequently coming out with new and very cool technology. But it's a new set of technology called operators. And so today we're very excited to have somebody back on the show who we had on a very long time ago when they were first getting started, but excited to have Brandon Phillips back on the show. Brandon, the CTO of CoreOS. Brandon, welcome back after a long time.
Yeah, absolutely. Thanks for having me.
I know we've had Alex on a couple of times. We've had Redbeard on, but it's good to have you back on the show again. So before we dive into this whole what's going on around operators and some of the cool things you're doing, give me your kind of 2 cents on KubeCon now that you've been back for a couple of days and kind of had a chance to reflect on it.
Yeah, so KubeCon was, pretty overwhelming. So if you think back on Kubernetes hitting 1.0, what was it, about 18 months ago, to go from a community that really started with a bunch of technology folks, CoreOS and Google and Red Hat, focusing on solving a handful of problems that they thought were important, to now having 1,000 plus people in the room talking about how they're using it and how they're deploying it and how it's making their operations better. It's a pretty huge transformation in such a short period of time.
Yeah, it was at times the event was a little bit overwhelming. 1,200 people, when you compare it to some other events, doesn't necessarily sound like a massive thing, but it was like you said, the technology kind of went from some incubation level stuff to all these relatively large name customers saying, hey, we're using it for our CI environment, we're using it for this set of applications, we're using it for all sorts of stuff, which was really, really promising, because I think a lot of times with newer technology, sometimes it's a lot of people talking about the what ifs, and this was a lot of people, really talking about, hey, I'm doing stuff with it and I want to make it, how do we make it even better, or, how do I get more involved? So that part was very cool. Let's talk a little bit about, you gave a keynote on day one. You were in the afternoon on day one. The day before, I think you guys announced this new thing called operators. Give us a sense of what's the problem space that operators is trying to solve, and kind of give us the basics of what it actually does in terms of capabilities.
Sure. So the big idea with operators and with my keynote overall is people get excited about Kubernetes because for a long time we've had this vision for, I always like to call it the operator's paradise, but this idea that we make it really easy to scale applications, we make it really easy to make applications that are tolerant to machine failures. We make it really easy to update and manage our applications over time. And really the unique opportunity that Kubernetes represents is we're putting APIs on top of a lot of the compute, network, and storage infrastructure that makes the back-end computing of the internet actually go. And with that opportunity, we're able to kind of use those abstractions, use those tools to take out some of the day-to-day toil of operating systems over a long period of time. And so we introduced this concept called an operator. And the big idea with the operator is that for a lot of the regular maintenance that you need to do in a complex system, instead of having these runbooks or these scripts, you have a piece of software that you declare what you'd like the system to be doing, and then the system drives state towards that. And it's essentially taking two core concepts inside of Kubernetes, the idea of a third-party resource and the idea of a controller, and gluing them together and making it simpler to operate complex applications on top of Kubernetes. So that's the big idea. It takes care of the scaling and the health recovery and that sort of stuff of applications.
Okay. So let's sort of walk through a few things just so people get the basics. And we'll never cover enough of this in the podcast. So you guys have a really awesome FAQ that we'll point to in the show notes so people can go kind of dive into, and a bunch of samples and stuff. So one of the things that people like about Kubernetes is, it is fairly easy to get an application on the platform. The scheduling, kind of the default scheduler that comes with the platform, and the ability to do some things like replicas is really easy. And people have kind of said, hey, we've moved towards it because some of the other things that were in the marketplace or in communities maybe were a little more complicated. So something like Mesos and Marathon, or sort of this two-tier type of thing. Is this a step towards Kubernetes kind of having to have more specific application awareness, or is this, is operators kind of a general purpose tool, but more driven towards kind of application awareness? I'm trying to get a sense of, where it fits in as people kind of compare it to other stuff.
Yeah. So the big idea of an operator is that, applications have their expectations of how they're configured. Maybe they have some administrative APIs, etc. And then Kubernetes has its own idea of like what copies of the application are running and where. An operator is really just a pattern, like a design pattern of how do you glue an application into the Kubernetes ecosystem in a way that's very, very Kubernetes native. And that's kind of the big thing that we're trying to do is, so we released two operators. We released an operator for a cloud native monitoring solution called Prometheus, and then we announced another operator for our distributed database called etcd.
Yep.
And so in each of these cases, we make it with just a few lines of Kubernetes resource configuration for you to be able to operate and deploy these more complex applications on top of Kubernetes in a really like Kubernetes native way. So it's really like, you can think of it as this glue that's sort of needed between a lot of the really cool software that exists today and making it not just work well on top of Kubernetes, but feel really like a native Kubernetes application.
Okay. So, and I mean, one of the big things that came out of this last week was, you have a concept in Kubernetes today called, used to be called pet sets. It's now called stateful sets. And people are kind of intrigued with this idea that, this platform can do more than sort of stateful applications, because for a lot of companies, they will write new applications at some point, or they will roll out new versions of a web front end or something, but there's still, a portion of their portfolio that's stateful. Where does this fit in with, kind of the work that already exists in Kubernetes to do some level of stateful types of applications or interactions with storage and things like that?
Yeah, so Kubernetes has all of the sort of primitives needed in order to run pretty much any Linux application that you've been running on a server in the past. So we have this idea of a stateful set, which is one path. Kubernetes can already mount persistent volumes. So if you need to run a database that has to have access to a shared block device, like an EBS device or maybe some SAN device, you can also do things as simple as ensure that this application runs on the exact same host every time, so that it has access to the files that it had before from just the local file system. And so in a lot of cases, if you have a stateful application and that stateful application has requirements around its IP address stability or its storage stability, you can absolutely model that under Kubernetes. Now, it gets a little bit more interesting when you may have a stateful application that's sort of, we won't say cloud native, but maybe let's say cluster native. And for those sorts of applications that, the class of applications being like sharded MySQL applications or read replica database, your Redis caches, monitoring systems, this is where you want to, we think a great pattern is this idea of an operator where you essentially glue these clustered applications with code that makes them aware of Kubernetes native concepts, and then you kind of have created a a native application on top of Kubernetes that is able to handle state, it's able to handle dynamic reconfiguration, it's able to handle dynamic service discovery. So that's kind of the big idea. So you can imagine us down the road. Today we have an etcd operator and a Prometheus operator, but we may have a Postgres operator or a sharded MySQL operator, et cetera, down the road.
Yeah. I mean, I can imagine people even looking to build a, like Kubernetes controller type of operator, the thing that'll sort of manage the system itself, or, backups of any, important type of application. There may be some capabilities to have awareness. So I think if I'm kind of looking at this, it's, there have been things in the past that would help people, like you said, build scripts or playbooks. This is really saying, look, if you're making a commitment to Kubernetes, you're going to try and build around the APIs, you're going to try and build around the concepts of it. This is that, one of those ways that you might go about keeping everything sort of in the native Kubernetes way of thinking about stuff, as opposed to a bunch of external systems that have different constructs that you have to translate into Kubernetes concepts, if you will.
Yeah, exactly.
Okay.
Exactly. So it's like, how do I take those runbooks and, like, now that I have all the power of the Kubernetes APIs, essentially automate the runbooks?
Right. Right. Now, I mentioned, having like a Kubernetes operator. One of the things I tend to do is look at, different platforms and so forth. So, for example, like in the Cloud Foundry world, there's this thing called BOSH, whose job is to kind of help set up the underlying stuff underneath, the Cloud Foundry platform. Is operator something that you could see evolving to becoming, if I want to add more nodes underneath what's going to be in my Kubernetes environment, or if I want to, replicate the controllers in a way that, they're going to be highly available or available for DR? I mean, is this something that could evolve that way as well, or is this really mostly focused on applications within, running on top of Kubernetes?
Yeah, so this is a great question, and this is really about the other keynote, which people can find a recording of online that I gave at KubeCon. And the other operator that we've started to build, and we haven't released anywhere yet, but is the idea of an operator that can actually upgrade Kubernetes itself. And so that's what I demonstrated on stage. But the idea is that we've been working along with the open source community inside of Kubernetes for about a half a year now, maybe a little longer, on this concept of self-hosted Kubernetes. So it gets a little noodly, so just hold on for a sec. But
now, was this the thing you guys were, I think, was it called like KubeBoot? Is that the name? Okay, yeah.
So we have an implementation called BootKube, but what self-hosted Kubernetes is trying to do is run all of the Kubernetes components on top of Kubernetes itself. So it gets a little recursive.
Inception, yeah.
Yeah, but so Kubernetes is really good at deploying applications in containers, and every component except for one component of Kubernetes, which is called the kubelet, which is actually the agent that lives on the host, is actually runnable in a container. So the scheduler and the API server and the underlying data store of Kubernetes called etcd that we built, all that stuff can run inside of containers. And so we built a tool called BootKube, which you can try out. It's open source. It's on Kubernetes Incubator, which sets up and deploys Kubernetes clusters using only containers to deploy the cluster. And then those containers show up in the Kubernetes API. And so if you want to make an HA Kubernetes, it's really easy. You just click the button from 1 to 2 and you scale the API servers up. Or if you want to scale up or upgrade, say, the controller manager, you can just edit the deployment, click save on the deployment from kubectl edit deployment, and it will do a rolling upgrade of the controller manager. And so you begin to imagine, like, this is a pretty powerful abstraction. You're able to manage the platform using the platform APIs itself, which means that over time you can imagine deploying Kubernetes and managing Kubernetes becomes two separate tools. So if I want to scale out the underlying infrastructure for my Kubernetes platform, I go and click the auto-scaling group in AWS, or I go plug in more machines and pixie boot them in my data center. And then no matter whether it's in AWS or it's in my own data center, I use the Kubernetes APIs to actually upgrade and scale Kubernetes. They're the two separate things, which means I get to utilize the exact same tooling no matter what environment I'm deploying the compute, networking, and storage for Kubernetes to manage. I can use the exact same APIs to manage Kubernetes itself. And so the thing that we demoed is that very similar to CoreOS Container Linux, with this powerful concept of Kubernetes self-hosted, we're able to let users just subscribe to a channel of Kubernetes, and they can say, I want to be running the alpha version of Kubernetes, or I want to be running the beta version of Kubernetes, and they can then click a button and the cluster will upgrade from one version to the next. And that's all automated using what we call a Kubernetes version operator. And it's a pretty powerful concept, and if you want to just try out the basics of it all, it's available today on the Kubernetes Incubator BootKube project. Interesting.
Yeah, so we'll definitely put a link in the show notes to that. So, I mean, it like you said, it does get to be a little bit of, you go, okay, it's this on top of this, but you know, we've always heard people talk about things like DevOps and how you've got to get this common language between teams, and you want to get common tooling. And I mean, it sounds like you guys are really trying to push the envelope around this idea that, you know, this is going to be a system that's, you know, where you're going to build the future of your applications. And one of the things you need, you know, you should be taking advantage of the fact that it is, you know, it can be, you know, it can take advantage of what containers do. It can take advantage of spinning environments up quickly. And you can think about it as a platform or as almost like an individual application, and use it, whether you're, like you said, on the ops side of things or on the development side of things. It's a powerful concept. You have to sort of think about it a little bit. You probably, you know, draw some pictures quite a bit, but no, that's cool. And you guys were showing, you know, kind of upgrading versions of Linux, but you can apply it to almost anything, I would guess, at that point.
Yeah, and I think it's easy to kind of get lost in the technical details, sure. But really what we're trying to get at is that, look, these Kubernetes and all this technology is fairly complex, and we don't want operators, we don't want the people who are in charge of this infrastructure to have to think about the details of everything, and we want them to be able to confidently do things like when a zero-day vulnerability comes out for Kubernetes or the underlying infrastructure, we want them to understand how they take action without necessarily having to be complete 100% experts in Kubernetes and its architecture. And really the only way to do that is through automation. And so all the tech is cool, but what we're really trying to do is build software, build infrastructure tools that let operators, let people essentially really effectively manage not the day one experience, but the, you know, day 365 experience of the infrastructure.
Yeah, no, and I think that's cool. I like the mindset of that, because I think we, for a long time, we've sort of built tools for developers and operators differently, and we've kind of left the operators behind sometimes, and making them feel like it was always, well, you're the bottleneck, and hence maybe we don't need you as much, or, you know, we can replace you with a cloud or whatever it would be. So that's cool. I like the mindset of that thinking, and it'll be interesting to see, you know, the feedback you get from people as it moves from incubation into other stages. So one of the other things, because you guys have been at this for a long time, you know, one of the other things I heard from a number of companies was, you know, them just sort of going, yeah, I heard some people talking about this, and they're trying to figure out, like, you know, does this really work in production? And I think that got proved out pretty well at KubeCon. But they're trying to figure out things like, can I replicate the environment? Can I back up the environment? How do I do what's the mindset that you kind of, you know, talk to people when they, you know, if they come from more traditional operations and they're bringing up those concepts? Is it a, hey, you know, here's the tools you use, or is it more of a mind shift change that you kind of go, look, things are immutable and you don't have to think about backing them up? Or what's that conversation look like?
Yeah, so that's there's a few facets to that conversation. First is that Kubernetes is just like your average web application. Its job is different. It's not going to be, you know, showing you cat pictures on a blog, but it's just like a regular web app. So it has a long-running service that responds to HTTP requests. That's the Kubernetes API. And then behind that long-running service is a database, and that's the etcd database. And so just like you would have to be concerned about backing up the MySQL of your WordPress, you need to be concerned with backing up the etcd instance and ensuring that either you're running etcd on top of a highly available replicated block store, which is what a lot of people do by running on top of EBS or running on top of a SAN in their data center, or you ensure that etcd you can kind of think of as having its own native RAID system. It will do replication for you between a lot of different machines, but you still want to back that thing up and maintain it and care for it just like you would any other important database. So that's one thing that you just got to be aware of, is like these systems hold on to state. You back up state on other pieces of your infrastructure. Do the same here.
Yeah.
The other piece is that despite all the like scariness and craziness of this technology, like during my keynote, I showed that I'm doing this live rolling upgrade of Kubernetes using the Kubernetes APIs. But the really important thing about Kubernetes is the whole thing is designed to fail very, very nicely. So I have actually a tutorial that I've given at a few conferences about what happens when Kubernetes fails, what happens when the components fail, what happens when pieces of the software stop, what happens if you lose load balancers. And to a large degree, Kubernetes is designed so that pretty much the entire thing can fall apart and your app keeps running. So your Linux processes aren't going to get killed, the firewall rules aren't going to get torn down, DNS will continue to resolve, etc. You're going to want to, of course, get Kubernetes back up and running, but you can have some pretty critical, terrible bugs inside of Kubernetes where it becomes 100% unavailable, and those processes that are actually servicing your user traffic don't go away. And I think the testament to why Kubernetes has gotten so much traction is that good, solid, experienced operations people can sit down for a couple days, understand the architecture, understand the failure concepts of Kubernetes, and actually feel like, you know what, I'm okay putting myself on pager rotation for this because it's something that I understand isn't going to lead to 100% catastrophic mess ups for me and my team. So
yeah, no, it makes sense. It's something I hear quite a bit from people is they feel like there are sort of clear delineations as to where a developer engages with it, what operators do, and obviously, you and Alex come from a background having done some really large scale operations. So it's good to hear that you guys kind of give it the thumbs up seal of approval, something that that you would have felt comfortable using and building and so forth. So let me wrap you up one last question, and we'll let you get back to your get back to things. So there's a couple of example operators that you've posted, one for etcd and for Prometheus, as you mentioned. Obviously, you talked about others that could happen somewhere down the road. Like, is there any talk within, say, the CNCF or hosted by CoreOS, will there be like a big repository where people can go grab these? As what's the intention for sort of where people will find these, or where if somebody says, hey, I have an idea for one that maybe you suggest they should put them so they could get reused by other people as opposed to being everybody's GitHub profile?
Yeah, for sure. There's been some talk about that, about creating like a GitHub org or something like that. We may do that sometime down the road. Right now, we've just been focused on introducing the concept, making the first couple solid. But I'd definitely be interested to see other people coming up with ideas, and if it makes sense, we can definitely create a home for these things. There's a lot of stuff that can be built, and I think what we've done with the etcd and Prometheus operators is really just scratching the surface, but really making quite compelling user experiences that teams of infrastructure and teams of engineers really have only dreamed of in the last few years. So.
Okay, very cool. Well, listen, before you go, what's the best place if people want to, reach out to you, talk about, what you've got going on at CoreOS, or, the projects that you're working on, or even just, the places you might be speaking again in the next few months?
Yeah, so a few different places. We are at CoreOS on Twitter. I'm at Brandon Phillips with one L on Twitter as well. And then we have an event in New York if people are interested, talking about Kubernetes called Tectonic Summit. That's happening on the 12th and 13th. I'll be speaking there. And then coming into the new year, we have KubeCon EU in March in Berlin. So that's a good one to keep your eyes on too if you're in the European time zones.
Very cool.
Besides that, CoreOS.com is where you can find everything else.
Excellent. Well, listen, as always, thank you for coming back. I know all the guys from CoreOS have always been very cool about keeping us updated on what's going on in the Cube world and the Giphy world, and we wish you guys the best of luck going forward. So thanks again for Aaron and for Brandon, folks. We appreciate you listening, and we will talk to you soon. Thank you.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.